This lecture is going to cover metric conversions. You will want to have a calculator for this, so go ahead and grab one if you do not have one already, and let's go ahead and get started. So, before we get started with actually using conversions and math with metric conversions, we have to understand what the metric system is. So the metric system is going to be based on a power of 10. And so that's just showing that things are multiplied by 10, or it's multiplied by 100, or it's multiplied by 1,000. So that's our power of 10. So the metric system is going to use a set of prefixes that will give us an idea of how large or how small a number is. You have probably seen a lot of these prefixes before, but we can look at it and see what the math is that kind of has to do with that. Another important thing to notice about this is a system that is used around almost everyone in the world. We are one of the exceptions here in the United States. But it is important to recognize that this is used across the scientific community. So a lot of you are saying, but why don't we just use inches and feet and what we are used to? Well, in science, this is the system that is used. So that is one reason that we use it in our classroom. So you will see a list of different prefixes here. You will see symbols that correspond with them. So something like my kilo, I'm underlining here, kilo has the prefix K. Then we have like milli down here has the prefix of a little m. So those are things that you will want to become familiar with. Don't worry too much right now about these two columns, about the multipliers and the exponents. We'll kind of get to that as we continue through this lecture here. The ones that you should be able to recognize and be able to use would be giga all the way through nano. So I'll erase these right here. Giga through nano. So it might be to your benefit at this time to pause the video and write down the prefix and write down the symbol that it corresponds with. Make sure that you are careful with if it is a capital or if it is a lowercase. The one that you may not be able to see too well on this because it's a little bit tiny is micro. So micro uses the Greek letter mu. So that kind of looks like this. It's like a U with a tail in the front. Okay, so one of the things you're going to have to be able to do is remember the order. So I have a little trick for you for remembering at least that middle part, so it doesn't include all of them, but these are the ones we'll use the most. So it's King Henry died by drinking chocolate milk. So King Henry died by drinking chocolate milk. If you remember that, you remember almost all of the prefixes and the order in which they are written. So you will see king corresponds with kilo, the H in Henry corresponds with hecto, D in died goes with deca. The only one that you'll notice is not a prefix is your base unit. So your base unit is going to be a term that does not have a prefix. So we don't just use these prefixes alone, we use them with a type of measurement. So maybe we're measuring length, we're measuring mass. So let's say we're measuring length. For kilo, we could have kilo meter. So this is the unit, the meter, that's the unit in which we are working. We are measuring length, so we use meters. So my base in this situation would be meter. The others that you will see is we will use liters, we will use grams, you've seen us use joules when we have done calorimetry. So these are pretty much the four that we'll use at this time that you will see. So you'll see meters, liters, grams, and joules. So I can add any of these prefixes over here. My milli, my centi, deci, deca, hecto, kilo, mega, giga, milli, nano, any of those I can add in front of a base unit. So at this base part here, that's when I have no prefix in front of it. So it's just meters. So this just kind of gives you a way to remember it. If you have a different way, go for it. All right, so the idea here is for us to be able to convert between units. So how do we move between units? So we're going to use what we call the factor label method. So in order to be able to use the factor label method, we have to be able to create what we call equivalence statements. So when you see this word equivalence, you should be thinking equal. So an equivalence statement will just show how two different units are equal to one another. So for example, an equivalence statement you are probably used to, hopefully, is that 1 day or 1 week equals 7 days. Sorry about that there. So we are all familiar with that 1 week is 7 days. That's an equivalence statement. These two values, but they are different units of measurement, weeks and days, but they are still equal to each other in their value. So just some other examples. 1 meter is equal to 100 centimeters. 1 meter is equal to 0.01 hectometers. So then the key is, okay, where do those come from? How do I get those values? Because 1 week and 7 days, that's just a common thing. We all know that. We didn't have to look at any chart. We didn't have to look at any table. We didn't have to do anything to know that one. But these other ones, these things right here, not common knowledge that you have. So we'll look at how you can figure those out by using the chart and table that we have. So all I've done here is take this chart here and just flipped it over on its side. So we just made it a horizontal chart instead of vertical. It makes it a little bit easier because now it kind of looks like a number line, and it makes it a little bit easier for us to go from one unit to the next just because we're familiar with a number line being horizontal and not vertical. So if you would like to write out your prefixes, I would go from here to here in a number line fashion. That's just fine. Don't worry about writing these at the bottom and these other ones at the top. You can write them all in one line. This was just so it could be condensed so it can get all on one page here for us. Now, when you are creating your own equivalent statements to give yourself some conversion factors, we're always going to use one of whatever our base unit is, and then we'll move our decimal from there. So we're going to be moving our decimal based on where these prefix values are on our number line. But we're always going to start with our base unit. That's the one that we always want to come back to. So the first one we're going to do is 1 meter equals X number of hectometers. So we need a conversion factor that shows our equivalence between meters and hectometers. So the first thing you want to do, find where your meters are on your number line. So that's going to be right here. That's at my no prefix. That's at my base. Next, go ahead and highlight where your hecto is. So hecto is down on the bottom here. So hecto is right here. So I'm trying to go from here to here. So if I have 1 meter, it's important to remember where's your decimal on this value. It's right here. It's after. And I'm going to move that 2 spaces. So I had to move 2 spaces to get from meters to hecto. So I'm going to move my decimal 2 spaces, rewrite my decimal point. Actually, I went the wrong way. Since I moved to the left here, I need to move my decimal to the left. 1, 2 spaces. Put that decimal in there, right here, and then fill in with a 0. So my answer for 1 meter is, 0.01 hectometers. Okay, let's do another example here. Our next one is, now I need meters to millimeters. So mark where you're starting. We're starting here at our base unit, and we want to get to milli, which is right here. So start with your value. I have 1 meter that I'm starting with. My decimal is right here after the number. Okay. And how many spots do I want to move? I need to go 1. There's 2. 3 spots. What direction did I go? I went to the right. So I'm moving 1, 2, 3 spots to the right. Putting down my new decimal. 1, 2, 3. So I have 1,000 millimeters in 1 meter. Okay, let's look at the next one. So this last one is micrometers. So these are going to be a little bit different. Your ones for micro and nano, mega and giga. So if you look here at your exponents, deci is 10 to the negative 1, centi is 10 to the negative 2, milli is 10 to the negative 3, and micro, it's really small, but this is 10 to the negative 6th. Okay, so whereas each one of these has represented 1 spot on my decimal, this space right here, let me do that in a different color for you. This space right here actually represents 3 decimal places that I'm going to move. Same thing between these and on this side as well. So we won't use these as much, but you want to remember that going from milli to micro is 3 spaces, micro to nano is 3 spaces, kilo to mega, 3 spaces, and then mega to giga is also 3 spaces. So if you're a little confused, let's do this example together and see if that helps. So I'm going to erase here. So once again, we're starting in our base unit, always going to start with 1 in our base. So I have 1 meter, remember that decimal right behind here. So let's highlight where we're starting and where we're going. We are starting at our base, and we are going to the micro, which is over here to the right. So I'm going to move 1, 2, 3, 4, 5, 6 spots. Okay, so see how I move 3 between the milli and the micro? So we said 1, 2, 3, 4, 5, 6 spots. 1, 2, 3, 4, 5, 6 spots. There's my new decimal. Fill it in with zeros. So then you're going to write that value in here. I'm not going to be able to fit that in that little line. All right. So let's keep moving on. Let's see what else we can do here. So once we have those equivalent statements, what we're going to do is we're going to use what we call the factor label method. So this is also referred to as dimensional analysis. You're going to see me call it dimensional analysis a lot more than the factor label method, but that's just what it's called. So what this does is it allows us to convert between different units. So if I wanted to convert from weeks to days, I would use that equivalent statement, and I would use what we call the factor label method. So as you move through the process, units must cancel out. Equivalent statements will be used to convert between different units. So we have been writing our equivalent statements like this. 1 day equals, 7 days. 7 days equals 1 week. Now, when we write it in the factor label method form, we're going to write it like this. We can write it as 1 week over 7 days. So we write it like a fraction, or we could write 7 days over 1 week. We can write it either way. So this is just showing that these two values, this one here is just showing that 1 week is equal to 7 days. This is showing you the same thing. It's just flipped. So we can write it either way. So the form of writing in the factor label method is writing it this way down here. This is your equivalence statement, just indicating that they're equal to each other with our little equal sign. That's what we just did. But this way right here is how we're going to use it to get our units to cancel out. So this canceling out part right here. All right, so some examples of how to use the factor label method as we are doing this. So if I have 578 centimeters, but I want to see what that value is in meters, I'm going to first develop an equivalence statement, and then I'm going to use the factor label method. So I want you to go ahead and pause. See if you can get yourself an equivalence statement for centimeters and meters. Remember to start with one of your base, so our base is meters. So pause it, find that, and come back and we'll use that statement. All right, so 1 meter equals 100 centimeters should be the equivalent statement that you found. So the way that we're going to do this and use the factor label method is you're going to start with what you're given. So I'm given that I have 578 centimeters. Okay, and then what I'm going to do is I'm going to do a multiplication and a division using this right here as an equivalence statement. So remember, I can write this two ways. 1 meter is the same as 100 centimeters, but I could also write it as 100 centimeters over 1 meter. Either one of these is a true equivalent statement for my factor label method. Now, which one do I use? The idea here is that your units are going to cancel. So my centimeters are going to be considered on top in this situation. So in order for my units to cancel, one has to be on top and the other has to be on the bottom. So what I mean by that is we would use this equivalence statement. So I have centimeters on top here, centimeters on the bottom here. That means that my units are going to cancel. One's on top, one's on bottom. They cancel out, and then I'm left with the unit that I want. And the unit that I want in this situation is meters. So, okay, I got my units to cancel. Now what do? I'm still left with this. It kind of looks like a mess right now, right? So what you're going to do is you multiply across the top, and you are going to divide on the bottom. So get your calculator out, have that handy. What you're going to do is you're going to take 578, let's change colors again, 578, multiply that by 1, and then you are going to divide by 100. Okay, so 578 multiply by 1, multiply across the top, divide by 100, you should end up with 5.78. So what we're saying here is there are 5.78 meters in 578 centimeters. Okay, so let's get most of this out of the way here. .78. All right, let's do another example here. 9,000 millimeters equals how many kilometers? So you're going to have two equivalent statements for this because remember you want to go from your base. So since neither of these are base units, we're going to have to do millimeters to meters, and we need another one that's going to give us meters to kilometers. So see if you can develop those two equivalent statements, starting your equivalent statement with having 1 as your base unit. Says both of these should be equal to 1 meter. Once you have done that, come back and we will take a look. Alright, so your two equivalent statements, you should have 1 meter is 1,000 millimeters, and then 1 meter is 0.001 kilometers. If you want to try this on your own, go ahead and pause it this time. Try it on your own, see if you can see what you get. If not, go ahead and work through this with me. So remember, I can write these one of two ways. I could have 1 meter over 1,000 millimeters, or I could write it as 1,000 millimeters over 1 meter. Then our one down here, I could have 1 meter over 0.001 km, or I could have 0.001 km over 1 meter. Okay, so either one of those, whichever one I need is the one that I can use. So I'm starting out with 90,000 millimeters. So I like to go ahead and draw my line, and then I can add in there what I want. Now, if I want millimeters to cancel, does it need to be on the top or on the bottom? It's going to need to be on the bottom. So which one of these has millimeters on the bottom? It's going to be this first one here. So I'm going to write this as 1 meter over 1,000 millimeters. But at this point, my millimeters have canceled, but I'm still in the unit of meters. That's the only one I have left, right? And I want to find this in kilometers. So I have to keep going. Now, you don't have to stop and start over. You can just continue it from here. So now, what unit do I want to cancel? I want to get rid of meters so I can get into that km that we're trying to find here. So if meters is on top, I need meters to be on the bottom. So which of these two down here that I wrote out has meters on the bottom? It's going to be the second one here. So that's 1 meter on the bottom, 0.001 km on the top. So now what happens to my units of meters? They are also going to cancel. Meters cancels, and I'm left with km, which is what I want. That's what the problem's asking for down here. Okay, now let's go ahead and do the math. Multiply across the top, and then you're going to divide. I like to go step by step, so what I would do here is I would take 90,000 in the calculator, divide it by 1,000. I didn't multiply by 1 because we know when we multiply by 1 that keeps the same value. If it makes you feel better to multiply by 1, go ahead and do it, but just remember, multiplying and dividing by 1, don't change your number. So I took 90,000 divided by 1,000, and then I moved to my next block here, and I'm going to multiply by 0.001, because that one is on top, and what I should end up with is 0.09 kilometers. All right, so go ahead. What I want you to do next is go to your grid, check out what you need to be doing. You're going to go to your explorelearning.com and do some practice problems with figuring out what equivalent statements you're going to do, and then we can go from there. Let me know if you have any questions, and good luck.